This is video 912, and in this video, the goal is to understand how to solve an inequality. Okay, so let's first take a look at what that means. In our first example, the problem might state solve 4x minus 1 is greater than or equal to 7. This is the first problem on your worksheet that you're trying to work on today. The first question I want to ask you is, what does solve mean? So for inequalities, what does that mean when we're solving? Solving means that you're trying to find the values for x that make this true. Okay, when we're doing an equation, we are trying to find a value for x that made it equal. Now we're doing a situation where we're looking at an inequality here, and we're trying to figure out when the left side will be greater than or equal to 7. So what x's make it true? Now, for instance, if I plugged in 100 for x, and it would be 4 times 100, that would work. That would be greater than or equal to 7, because it'd be 400 minus 1, and we would get 399, greater than or equal to 7. So 100 is a solution to this situation, this inequality, but the question that we really want to answer is, what does it mean? We want to find all the solutions in the world that would be a solution to this equation. So solving means to find values for x, I should say to find all values for x that make the inequality true. Inequality, spelled this way. Inequality. We want to figure out what will make the inequality true. That's our number one goal here. We're trying to find all solutions. Okay, so it takes steps, thankfully, that are similar to your equation solving skills. And the first step that I want you to think about is to solve it as an equation. That's our first step. So I'm going to take 4x minus 1 greater than or equal to 7, and I'm going to write it as an equation. And that's my first step. I'm going to solve the equation. So this will be simple. I can solve these equations. Add 1 to both sides. I get 4x's alone equals 8. X equals 2. Oops, I kind of did a step in my head there, but I divided both sides by 4. So I get x equals 2. Okay? So that's my first step. I got what was called the boundary point. Okay? Step 2 is to start by graphing the boundary or the solution to your equation with a circle that's open or a circle that's closed. Okay, so remember, we're going to make a number line to describe our solution set, and our number line is going to have an open, this is called an open circle, and this is called a closed circle. We're going to decide if it's open or closed based on the original inequality. See this inequality? See the symbol greater than or equal to? The fact that I just said equal to is because of that line underneath, and that means that x could be equal to 2. So I want to use a closed circle because it can be 2 because of the word equal and that symbol up there. Now remember, if it just had greater than with no equal to, we would do an open circle. So we'll summarize that at the end here and leave that up for you to use to remember. So I'm going to graph at 2. I'm going to make a closed circle because it can be equal to. Okay? So that's our next step. We graph our boundary point. Now what we're going to do is figure out which way to draw our arrows. So remember, the solution set is going to either be a closed circle with an arrow going to the right, or maybe it's a closed circle with the arrow going to the left. I'm going to point in the direction of the solution. So what I'm going to do is test one solution. I'm going to test a number that's easy to work with, and I like to test the number 0. So what I'm going to do is plug in 0 into my original inequality, so with the greater than equal to symbol. And I'm going to ask myself, is this true? So I'm going to do the math. Let's see, 4 times 0 is 0, minus 1. So I get negative 1 on the left. And I ask myself, is that greater than or equal to 7? and I look and it is absolutely not greater than or equal to 7. It is very much less than 7. So that means my solutions are in the opposite direction of 0. Okay, because 0 was not a solution, I draw my arrow the other way. And this is a description of my solution. So step 3 that we just did is check another number and draw the arrow on your graph. Okay, so we checked another number and we drew the arrow. So we have to point in the direction of the solution. So apparently if I plugged in like 3 and 4, they should work in my inequality, just like I did in blue there. The last step is to write the inequality. The final thing, draw the arrow and write the solution. We want to describe the solution instead of having to draw the graphs. We also want to describe the solution. It looks like x needs to be greater than or equal to 2. Because these points that are on this circle says that it can be equal to because it's colored in. That's why I did this. And because I drew in the greater than direction, that means that x has to be numbers bigger than 2. So this whole thing right here describes my solution. So this right here describes my solution for this inequality. It's all numbers bigger than or equal to 2. And we kind of knew that from the first problem. When I said, hey, look at 100, 100 would work, we knew that numbers that are big will definitely work. So let's give it a shot with another problem. So remember, we start by solving the equation, and then we're going to go about and graph the inequality. So we're going to write it as an equation first. Equals 3 instead of less than or equal to. And I'm going to solve just like I know how to do. So I'm timesing it all by 2. I distributed the 2. Now I'm going to add 10. Looks like I get 2x alone equals 13. Final step is dividing by 2. I get x equals 6.5. So not a nice number, but I can graph that. That's not impossible. So I like to always put 0 on my graph, and then I just jump to the next number. It's somewhere over here. You can put all the numbers in between there, but as long as everyone knows where 0 is, I think you're okay with setting up your graph like this. So let's see, I'm going to put my circle at 6.5 because that's my boundary point. Now I got to decide, is it colored in or not? Remember, we looked at the original inequality. That symbol says that it could be equal to 3. So that means that I'm going to color it in whenever it can be equal. So apparently 6.5 is part of my solution set. Now I plug in a number into my original inequality. So I go back to my original inequality with the less than or equal to 3. And I'm going to plug in a number. I like to plug in 0. So where x is, I'm going to put 0. And I'm going to check if the left side is less than or equal to 3. So let's do the math. 2, let's see, that turns into negative 5. And I get negative 10 on the left. And then I look at the statement. Is this true? And we read it. Negative 10 less than or equal to 3. That is true. So that means my solutions are in the direction of the number I plugged in. I plugged in 0, so my solutions are in the direction of 0. And that's why I draw my arrow to the left. Don't forget your final step of writing your inequality with x. We're going to describe all the numbers on this line. And 6.5 goes in our description. And it looks like x has to be less than 6.5 because we're going in towards the negatives here. So x is less than or equal to, remember the equal to because it's colored in, x is less than or equal to 6.5. Here is your solution to this inequality. Okay, so remember those major steps. You're solving an equation, then you're testing a point. Okay, but the important part is you're gonna have to get the following slide memorized. So this right here reminds you of when to color it in and when to not. Which symbols do we color in, which ones do we not color in? The top two here, we're going to color in the circle. When it's less than or equal to, see that equal to in that line underneath? And when it's greater than or equal to, we have a colored in circle. When it's strictly less than or strictly greater than, we leave it as an open circle. So either write this down or keep the video open and looking at this screen so that you remember how to decide when to color it in, because that's going to be a common mistake. Okay, so make sure you're asking your teacher if you're stuck or have questions or you want your answers checked.